lesson on how to solve horizontally launched projectiles. In this video, we will review the characteristics of projectile motion. We will solve 3 horizontally launched projectile problems. The first one we will solve completely. The second problem we will solve by sketching it, identifying the variables, and solving for time, but we'll leave you to solve for the final variable. And in the third problem, we will leave you to solve for time and the unknown variable, but we will help you by identifying the variables and sketching the problem. Lastly, you'll be directed to some practice problems. In a previous lesson in physics, we learned that all projectiles are in free fall, which means the only force acting on projectiles is the force of gravity. Because gravity is the only force acting on them, the following holds true. The horizontal acceleration is 0. Because my horizontal acceleration is 0, I am not speeding up, I am not slowing down, and I am not changing directions in the horizontal direction. So my velocity in the x direction is constant. That means my starting velocity, my final velocity, and my average velocity are all the same number. So for horizontally launched projectiles, we just write the velocity in the x direction as v sub x. Horizontally launched projectiles also travel a horizontal distance or horizontal displacement. We call that change in x. So change in x is the horizontal displacement. In the vertical direction, because it's an object in free fall, the acceleration in the y direction is equal to the acceleration due to gravity. So in this case, we're going to call it negative g because it's acting downward. So it's negative 9.81 meters per second squared. And my velocity in the y direction changes constantly at a rate equal to g, meaning it gets faster on the way down by 9.81 meters per second in each second of motion. The initial velocity in the y direction, we write that as vi sub y is equal to 0. For all horizontally launched projectiles, the horizontal initial velocity is equal to 0, and then it speeds up on the way down. This red arrow represents the velocity as it speeds up on the way down. It also starts out at some initial position, y sub I, meaning my initial position in the vertical direction, and ends at some final position in the y direction. We usually make that final position 0. So therefore, my displacement in the y direction, my change in y, is yf minus yi, or 0 minus yi. So my displacement in the y direction, change in y, is equal to the negative of my initial position. So all that means is, say, for example, if this cliff were 100 meters high, my displacement is negative 100 meters, right? Displacement is a vector. It has a direction, so it has to have that negative sign with it. But my position, my initial position is a positive number. To solve any physics problem, you should read the problem, identify the variables, and assign a letter to each variable. Make a sketch of the situation and label all the variables in the sketch. Identify your equations to use to solve the problem. Plug and chug the numbers, and then check your answer for reasonability. The trick with projectile problems is to recognize that perpendicular components of motion are independent. There are 2 motions going on at the same time. We have a horizontal motion and a vertical motion. They combine to give us our parabolic projectile motion. So the trick for solving projectile motions is to recognize that they're separate, but they share the same time. So usually you have to solve for time in one direction, either horizontal or vertical, and then plug that time in to the opposite direction. So let's solve our first problem. The problem reads as follows. An eagle is flying towards its nest at a speed of 27 meters per second. That is my horizontal velocity, or v sub x. The nest is 115 meters away. That is my horizontal displacement, or change in x. From what height should the eagle drop the fish in order for it to land in the nest? So they want me to find what is my initial y sub I, my initial starting height in order for that fish to land in the nest. So it looks something like this. My bird is flying along up here, and here's its nest. The nest is 115 meters away. My bird is flying along at a velocity of 27 meters per second. That never changes. It's always 27 meters per second in the horizontal direction. My initial velocity in the y direction is equal to 0, and then the fish drops from the bird's mouth, and the fish speeds up as it falls. It starts here at some initial position. That's what they want me to find. It ends down here, my final position of 0, or the nest. My change in y is equal to negative yi. So that's what it looks like. So the first step is to find my time, and in this situation we're going to find the time in the horizontal direction and then apply that time to the vertical direction. So again, I've listed all my known variables. My Vx is 27 meters per second. My change in x is 115 meters. My initial velocity in the y direction is 0. My acceleration in the y direction is negative g, or negative 9.81 meters per second squared. And I'm looking for my initial position. What is my initial position? So the first thing I need to do is I need to find my time, and I'm going to do that but in the horizontal direction. So the equation horizontally is this: Vx is change in x over time. Just the basic velocity equation. But I'm looking for time, so I want to isolate time by itself, so I'll multiply both sides by time. My times cancel out, and then divide both sides by v sub x, and my v sub x cancels out over here, so I'm left with this. Time is equal to my change in x divided by my v sub x, or 115 meters divided by 27 meters per second. When I do this, my meters cancel each other out, so I'm left with a unit of seconds. And I get a time of 4.259 seconds with two significant figures, because that's all my problem has. My time is 4.3 seconds. If they were asking me for the time of the fall, that would be my answer, 4.3 seconds. However, I need to use the time in order to find my initial position. So when I go to find my initial position, I'm going to use this long time, not the rounded time, because it just helps with my answer. So now my next step is I need to take this time of 4.259 seconds and apply it to the vertical direction. So now I have added my time to my list of known equations. Time is 4.259 seconds. My initial velocity in the y direction is 0. My acceleration in the y direction is equal to negative g. And I'm looking for my initial position, or change in y, which is a negative yi. So I'm going to look at my kinematic equations that we learned in the very first units of physics this year and choose the equation that has displacement, time, initial velocity, oops, and acceleration in the equation. So I look at my equations, and I'm going to choose this equation. D for displacement is my initial velocity times time plus 1/2 times AT squared. So again, I don't have those same variables. I've called my variable something else, so I need to substitute in my variables. So instead of D, I'm calling it change in y. Right? And we said before my change in y is equal to my negative yi. My initial velocity is my initial velocity in the y direction times time plus 1/2 negative g, that's my acceleration in the y direction, times t squared. Hopefully you recognize that your initial velocity in the y direction here is equal to 0. So when I plug that into my equation, 0 times time is 0. So I have this, my change in y, or negative yi, equals 1/2 times negative gt squared. So now I'm simply going to plug in my numbers and get my answer for my change in y. So 1/2 times negative 9.81 meters per second squared times 4.259 seconds. And again, that time gets squared. I am left with an answer of change in y is negative 88.972 meters. With 2 sig figs, my change in y is negative 89 meters, which means my starting position is 89 meters above the ground. We will do a quick check to see if this makes sense. My units are in meters, which makes sense. I'm looking for a position. Position has to be in meters. It's a positive number, meaning my position is above the ground, so it's in the up direction, 89 meters. So for this eagle that is flying along, where the nest is 115 meters away, it needs to drop the fish from a height of 89 meters in order for that fish to land in the nest. Our next problem reads, a drone is 62 meters above the ground and flying horizontally. So this 62 meters above the ground, that's my initial position. I start out here, my yi is 62 meters above the ground. The drone needs to drop a package on a target that is 61 meters away. That is my horizontal distance. So that means my target where I want my drone, my package to land is change in x or 61 meters away. So it doesn't really give us a lot of information, but we know some other things. We know that my initial velocity in the y direction is equal to 0. My acceleration in the y direction is equal to negative g. And they want me to find my velocity in the x direction. How fast is my drone flying in order for it to reach a target that's 61 meters away if it's at a height of 62 meters? My velocity in the x direction is my change in x over time. We know my change in x is 61 meters, but we don't know time. So we're going to have to solve for time horizontally. Solve for time vertically and then plug it into the horizontal equation. So again, I'm flying at a height of 62 meters. It's going to land on the ground, what we call 0. So my change in position, or YF minus YI, is 0 minus 62. Negative 62 meters is my vertical displacement. So again, we're going to solve for time vertically and then find my horizontal speed. So since we're solving for time vertically, we need to go back to our kinematic equations and choose the one that has all of our variables. We know our displacement is negative 62 meters. We know our initial velocity is 0. We know our acceleration is negative g, and we're looking for time. So again, I'm going to choose the same equation that I used before. I'm going to rewrite it over here. D is VIT plus 1/2 AT squared. But now I'm going to substitute in my variables. So my displacement is change in y. My initial velocity is VIY times time plus 1/2. My acceleration is negative g times t squared. And so again, my initial velocity in the y direction is 0. So this quantity here goes away. So I'm left with this change in y is 1/2 times negative g times t squared. I'm looking for time though, so I have to isolate time and get it by itself. So I'm going to multiply both sides by 2. When I do that, that 1/2 cancels out, and then divide both sides by negative g. So I am left with t squared equals 2 times my change in y over negative g. I'm going to take the square root of both sides in order to find time. So time is 2 times my change in y over negative g. So I get Time is the square root of 2 times negative 62 meters divided by negative 9.81 meters per second squared, which is the square root of 12.64. My units, the meters cancel out, so I'm left with seconds squared. I take the square root of 12.64. I get a time of 3.5553. Take the square root of seconds squared. I get seconds. Again, since it's a square root, it's plus or minus, but we can't have negative time. So my time is 3.553 seconds with 2 sig figs, 3.6 seconds. And so now I need to take that time and apply it in the horizontal direction. So I'm going to let you solve for your horizontal velocity now that you know your time. Pause the video here to see what you get. You should have calculated a velocity in the x direction of 17 meters per second. And the way you get that is just from the horizontal equations, which is this. Velocity in the x direction is change in x over time. My change in x was 61 meters. My time that I just solved for was 3.5553 seconds. I end up with 17.168 meters per second, but I can only have 2 sig figs. So I'm left with 17 meters per second. It is my velocity in the x direction. Now we'll solve one more problem together. You should have found that it takes approximately 4.2 seconds for the binoculars to reach the ground, and they will have traveled a horizontal distance of 50 meters. If you did not get those answers, here's how I found that information. To find my time, I used my kinematic equations in the y direction. So I chose that same equation from before, d equals VIT plus 1/2 AT squared. I subbed in my variables, so change in y is equal to my initial velocity in the y direction times time plus 1/2 times negative gt squared. But VIY is 0, so that goes away, so I'm left with this. Change in y is 1/2 times negative gt squared. Solving for time, I get time is the square root of 2 times change in y over negative g. And that got me 4.2 seconds. And now to find my horizontal displacement, I use this equation. Vx is change in x over time. I know Vx, I now know time, but I'm looking for change in x. Multiply both sides by time. They cancel out, so my change in x is my velocity in the x direction times time, or my 12 meters per second times the time I just calculated, 4.187 seconds, or 50 meters. Now it's your turn to practice solving some horizontally launched projectiles. If you sign into our Google Classroom page, you will find a link to Turd the Target from the physicsclassroom.com. There are several problems there. When you are done solving those, take a screenshot of your completed activity and upload that to our Google Classroom. Please feel free to go back and watch this video again as you're solving the Turd the Target problems to help you. And hopefully you recognize this, that in the horizontal direction, the only equation that you need is this. My velocity in the x direction is change in x over t. And in the vertical direction, you're using the old kinematic equations from before, but applying all the vertical parameters. And so you have this change in y is your initial velocity in the y direction times t plus 1/2 times negative g t squared. My VFY squared equals VIY squared plus 2 times negative g times change in y. My VFY is equal to my VIY plus negative g times t. And last, change in y is equal to VIY plus VFY all over 2 times t. So again, these are just the basic kinematic equations from our very first unit of the year, but I've substituted in my parameters for projectile motion. Thanks for watching.